In this video, we'll explore shell script arguments. We'll learn how to pass command line arguments to bash scripts, and how to process them effectively. By the end of this video, you will be able to write flexible and reusable scripts that can adapt to different inputs. Command line arguments are values that are passed to a script when it is executed. They allow scripts to be more flexible and reusable, enabling different behaviors based on the input provided. These arguments are commonly used in automation tasks and system administration, making scripts more versatile. You can access these arguments through special variables within shell scripts. For example, command line arguments can be used for file operations on specified paths, processing data with custom parameters, configuring script behavior at runtime, passing user input to background processes, and creating versatile command line tools. In shell scripting, several special variables are used to access command line arguments. The variable $0 represents the name of the script itself. $1 through $9 represent the first 9 arguments passed to the script. For arguments beyond the 9th, you can use $ followed by curly braces, and then the argument number such as $open curly brace 10 close curly brace. $# represents the number of arguments passed. $@ represents all arguments as separate strings, while $* represents all arguments as a single string. Here's an example script. The first line, #bang /bin /bash, specifies the interpreter for the script. The echo command displays the script name using $0. Similarly, it displays the first argument using $1 and the number of arguments using $#. Finally, it displays all arguments using $@. Let's walk through an example that demonstrates how to use basic arguments in a shell script. The script, named args_demo.sh, begins with the shebang line. It then uses the echo command to display the script name using $0. It also shows the first, second, and third arguments using $1, $2, and $3 respectively. The number of arguments is displayed using $#, and all arguments are shown using $@. To run this script, first make it executable by using the command change mode +x_args_demo.sh. Then, execute the script with the command ./args_demo.sh followed by the arguments apple, orange, and banana. The output shows the script name, the first, second, and third arguments, the number of arguments which is 3, and all the arguments. The variables $@ and $* are used to access all command line arguments, but they handle them differently. $@ treats each argument as a separate quoted string, preserving the argument boundaries. $*, on the other hand, treats all arguments as a single string. The difference becomes noticeable when used within double quotes. It's recommended to use $@ when you need to preserve the argument boundaries and $* when you need all arguments as one entity. Here's a script to illustrate this difference. The script begins with the shebang line. It then uses a for loop to iterate through the arguments using $@ within double quotes, printing each argument separately. Following this, it uses another for loop to iterate through the arguments using $* within double quotes, again printing each argument. This example will highlight how $@ preserves the separation of arguments, whereas $* combines them into a single string. Loops are often used to process command line arguments in shell scripts. You can iterate through all arguments using a for loop with the $@ variable, processing each argument individually. Alternatively, you can use a while loop with the shift command to achieve the same result. The shift command removes the first argument, shifting all other arguments down by one position. Here's an example script. The first part of the script loops through all arguments using $@ and prints each one. The second part uses a while loop to iterate through the arguments. Inside the loop, it prints the first argument using $1, and then uses the shift command to move to the next argument. Both methods achieve the same outcome, allowing you to process each argument provided to the script. Parameter expansion is a powerful feature in shell scripting that allows you to handle default values for variables, especially useful for command line arguments. There are several techniques. The first is $open curly brace var hyphen default close curly brace. It uses the default value if var is unset or empty. The second is $open curly brace var equals default close curly brace. It sets var to the default value if it is unset or empty. The third is $open curly brace var question mark error message close curly brace. It displays an error message if var is unset or empty. And finally $open curly brace var plus value close curly brace. It uses value if var is set, otherwise it expands to empty. These techniques are particularly useful for providing fallback values when optional arguments are not provided. Here's an example script that demonstrates these techniques. The script sets default values for file name, count, and mode, using parameter expansion. If these arguments are not provided when the script is run, the default values will be used. Additionally, the script checks if a username is provided, and if not, it displays an error message. Parsing command line options in shell scripts can be efficiently done using the getopts command. Getopts allows you to handle flags and options in a standardized way, making your scripts more versatile and user-friendly. Here's an example script. The script uses getopts to parse options such as F for file name, N for count, V for verbose, and H for help. The colon after an option indicates that it requires an argument. The case statement then processes each option accordingly. If an invalid option is provided, an error message is displayed. Finally, the script prints the values of the options, using default values if they were not provided. This approach simplifies the handling of command line options, making your scripts easier to use. To write robust and user-friendly shell scripts that utilize command line arguments, consider the following best practices. First, always validate arguments to ensure that required arguments are provided and that they meet the expected format before processing. Second, provide default values for optional arguments using parameter expansion, such as $open curly brace, var, hyphen, default, close curly brace, to handle cases where arguments are missing. Third, include help information by implementing a -h or -help option that displays usage instructions to guide users. Fourth, use getopts for handling flags and options in a standardized manner, making your scripts more organized and easier to maintain. Fifth, always use quotes around variables such as $var to prevent word splitting and globbing issues that can lead to unexpected behavior. And finally, handle special characters by being prepared for arguments that contain spaces, quotes, and other special characters, ensuring that your script can handle a variety of inputs gracefully. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.